watch an amazing video?
I am.
Do you think you could go get my computer for me?
Yeah, I'll go grab my bow.
Tangents, but up in the schoolhouse an absurd little nerd is stopping you from saying boo-hoo, boo-hoo.
Work is done on the bow, which adds energy to the system. This energy is stored as spring potential energy in the limbs of the bow.
Next, as the energy is released, the potential energy in the bow is converted to kinetic energy of the arrow. Since energy is conserved, the kinetic energy of the arrow is then equal to the initial kinetic energy of the arrow, which is equal to 0, plus the initial potential energy of the bow, plus the work done on the system.
The arrow hits a box balanced on the edge of a deck with a force equal to the mass of the arrow times the acceleration. This is a demonstration of Newton's third law because the arrow hits a box, providing a force to knock it over the edge of the deck, but the box hits the arrow back with an equal and opposite force, which stops the arrow's motion.
As the box falls, it pulls on the rope attached to it with a force equal to the mass times the gravitational acceleration on the box. This force is then transferred through the rope as tension.
The tension of the rope pulls the trigger on a crossbow. This releases the bolt. In this system, potential energy stored in the spring arms of the crossbow is converted to kinetic energy of the bolt. Since the kinetic energy of the bolt is 0 initially, the kinetic energy of the bolt afterwards is equal to the potential energy stored in the limbs.
The crossbow bolt hits another box and knocks it over, and given Newton's first law, the box stays at rest until acted upon by the outside force from the arrow.
The box is knocked over due to the force of the arrow hitting it. Gravity also helps its path towards the ground. The force the box creates as it falls is transferred through a string as tension. This pulls a magnet off of the side of a beaker.
The magnets which are inside of the beaker are no longer held by the magnetic field of the outside magnet. They then fall with a force equal to their mass times the acceleration due to gravity.
The magnets collide with the yeast floating on the surface of the hydrogen peroxide in the beaker. Momentum of the magnets is conserved as it collides with the yeast, and the system of yeast and magnets continues its motion due to the momentum until it is under the surface of the hydrogen peroxide.
With more surface area of the yeast catalyst exposed to the hydrogen peroxide, this decomposition occurs rapidly and forms water and oxygen gas. Since the system is closed, this buildup of gas increases the pressure inside the balloon.
Since the balloon is inflated slightly due to the increased pressure of gas, it applies an outside force to the car, resting on the top of a ramp. In accordance with Newton's first law of motion, the box remains at rest until the outside force acts upon it.
This car then rolls down the hill, and it gains momentum as gravity acts upon it in the parallel to the plane.
The car collides with the system of a roll of tape in contact with a ball balanced on the edge of the deck. Momentum is conserved in the collision and is transferred from the car through the roll of tape into the ball. The ball rolls off the edge with the same momentum that the truck hit it with, but a smaller velocity since the ball had a larger mass than the truck.
The ball, now falling, exerts a force onto the attached rope equal to its mass times the acceleration due to gravity. This tension transfer led via the pulley, which tears the weakly attached tape and allows the cardboard holding the ball to shift over the blowtorch.
Propane gas contained in the canister attached to the blowtorch combusts according to the formula C3H8 plus 5O2 is equal to 3CO2 plus 4H2O. This reaction releases approximately 2,000 kilojoules per mole. Energy is conserved in this reaction, as the chemical potential energy of the propane is equal to the potential energy of the products plus the thermal energy released. The thermal energy released by the reaction is sufficient to provide the activation energy for the combustion of cellulose, which composes cardboard. As the solid cellulose is converted to gaseous carbon dioxide and water, it no longer provides a tension force to cancel out the force of gravity acting on the bowling ball parallel to the plane.
This bowling ball now rolls down the ramp, gaining its momentum. This provides a tension force on the string, which pulls a piece of tape off the wall.
The piece of tape being removed from the wall allows the gravitational potential energy of the hockey puck to be converted into kinetic energy as it swings like a pendulum. As it swings back and forth, potential energy and kinetic energy are converted in between each other, but the total of them added together will always be the same in accordance with conservation of energy.
The puck hits into the books and transfers all of its momentum to the books, which in turn then fall and knock over a filled cup.
The water in this cup, now knocked over, pours into another cup, which is attached to a pulley system, and in turn, another cup. As the water falling into the cup increases its mass, the force due to gravity on it becomes greater, and eventually it surpasses the force of gravity the other cup exerts on the string, which pulls the filled cup down over the edge of the table, and the other cup up.
The cup then collides with the car balanced on the edge of the ramp. This car then remains at rest until this outside force acts upon it.
The car gains momentum as it rolls down its ramp, and collides with the puck resting on the edge of the table.
Momentum is now conserved as the puck falls off the table due to its new momentum.
As the puck swings down, like a pendulum, some of its potential energy due to gravity is converted to kinetic energy in such a way that the initial kinetic energy plus the initial potential energy is equal to the final kinetic energy plus the final potential energy.
This puck collides with a stack of pucks. The swinging puck hits the stack with a force to send the pucks flying from their perch. The pile of pucks hit the swinging puck back with an equal and opposite force to stop the swinging puck.
Now that the pucks have been moved from their initial perch, they no longer provide a tension force to the string connected to the hammer.
The hammer, no longer held up by the tension force, falls due to the gravitational force and hits the spacebar, playing the greatest video of all time.